Let's discuss the question number 31 from test 5. This is from thermodynamics. Let's read the question. 1 kilomole of ideal gas is throttled from initial pressure and temperature. And the final pressure is given, and we are asked to find out the entropy change of the universe. Okay, so the process is throttling, and it's a closed system. Okay, so initially I have my pressure as 0.5 MPa and temperature as 300 Kelvin, and this is throttled. Throttling is some kind of passing the fluid into some dirt, porous dirt, where there is always some kind of obstruction devices, where there is always a pressure drop. Okay, so no, and it can be insulated depending on the situation, and cannot be also. So, but always its throttling is some kind of an obstruction device like a capillary tube or a flow passing through a porous dirt, where always there is a pressure drop. That is for sure. Okay, the final temperature is not known. Okay, so what are we supposed to find out? We are supposed to find out the entropy change of the universe. So entropy change of the universe is basically entropy change of the system plus entropy change of the surroundings. Okay, so now entropy change of the system. Now let's see how to find out the entropy change of the system. Okay, now here another so for system one can directly use this TdS equations. Always one can use the TdS equations for finding the entropy change. Okay, so now how do we calculate each of these terms? Now dH and VdP. Now what is given is it's an ideal gas. So ideal gas means one can use this dH is equal to Cp dt and du is equal to Cv dt. These two relations are for ideal gases. Okay, now so what does throttling mean? Throttling means so whenever a throttling takes place, how does throttling takes place? I mean, if you use the first law, or general, if you use the basic throttling thing, so throttling enthalpy remains constant, H1 is equal to H2, so dH is basically 0, and once dH is 0, it means that T2 is 0 and temperature is constant. So basically T2 will be same as T1, which is 300 Kelvin. Okay, and similarly once dt is 0, I will have du also 0 because it behaves as an ideal gas. See, for the ideal gas, the enthalpy change and the internal energy change are related to temperature. So but we know that in a throttling enthalpy is constant, so your temperature change is constant, and once temperature change is constant, from this equation my internal energy is constant. Okay, so let's use this TdS equation. So dH is 0 minus VdP, and as it is ideal gas, I can write VdP by T, and so PV I can write nRT, it's a kilomole, where R is my universal gas constant. So V by T can be written as nR by T, so this will be basically minus nR by T dP is ds. So now let's integrate. So I'll be getting S2 minus S1 from one state to the second state, equal to nR ln P2 by P1. Okay, so 1 kilomole and universal gas constant is 8.34 into ln P2 is 0.1, P1 is 0.5. So because of this minus, it goes, and the ln, the denominator becomes the numerator, so I can write 8.314 ln 5, and that value comes out to be 13.38 kilojoules per Kelvin. Okay, so now let's find out the so we have found out the entropy change for the system. Now let's see whether there is some entropy change for the, now because my du is 0, and throttling means, let's see whether there is any heat loss to the surrounding or heat added. Now because let's use the first law, dq is equal to du plus dw. Work done, it's generally 0 because it's just some kind of an obstruction. Or for closed system also, work done will be 0 in throttling, and du we have seen it is 0. So basically there is no heat loss. Heat loss is not there, and the system is insulated. So as there is no heat loss to the surroundings is not there, so there is no heat supplied to the surrounding and the system is insulated, so delta S of the universe or of the surroundings is basically 0, because there is no heat added to the surroundings and no heat there is no heat interaction with the surroundings, so delta S will be 0. So now delta S of the universe will be basically delta S of the system plus delta S of the surroundings, and we got delta S of the system as 13.38 and surrounding as 0, so the answer is 13.38 and therefore the option is A. Thank you.